we are going to discuss about Reynolds experiment. Reynolds first identified that the flow changes from laminar to turbulent not only depends on the velocity of flow but also depends on diameter of the pipe and viscosity of the flowing liquid. Right? Reynolds first identified that the type of flow is not depends on the velocity of flow but also depends on diameter of the pipeline and also viscosity of the flowing liquid. Right? Now, Reynolds number, the type of flow in the pipes are classified, that means that are the laminar flow or turbulent flow or transition flow is classified based on the Reynolds number. Reynolds number Re is equal to rho V d by nu. Right here, rho is nothing but mass density of the flowing liquid. Suppose the flowing liquid is water, rho equal to 1000 kg per meter cube. V is the velocity of flow, that is in meter per second. D is the diameter of the pipeline, and mu is the viscosity. Viscosity units Newton second per meter square or poise. Poise is the units of viscosity in a CGS system. In SI system, Newton second per meter square. This is the Reynolds number. Suppose we are going to determine the Reynolds number based on the density, velocity, diameter, viscosity. So this Reynolds number is less than 2000. The calculated Reynolds number is less than 2000. The flow is known as laminar flow. If the Reynolds number is more than 4000, the type of flow is known as turbulent flow. Whereas this Reynolds number value in between 2000 to 4000, the type of flow is known as transition flow. Right? This is Reynolds number is less than 2000. Reynolds number is less than 2000, that is laminar flow. Reynolds number is in between 2000 to 4000, that is transition flow. Right? The type of flow is identified with the help of Reynolds experiment. Now we are going to conduct the Reynolds experiment for the identification of type of flow. The type of flow is determined from the Reynolds number, that is already explained to you. This is determined by O. Reynolds in 1883. Right, now we are going to conduct the Reynolds experiment. What are the operators required for the conducting Reynolds experiment? The operators required for the Reynolds experiment are, first one is a tank containing water. A tank containing water. A tank containing water, and this head in the tank is maintained, constant head is maintained in the tank. That is the first one. And second one, small tank containing some dye. This is the small tank. This is the small tank containing dye. And another component part, another operator, a glass tube with bell-mouthed entrance. A glass tube with bell-mouthed entrance at one end, and a regular valve at the another end. This is the valve. This is the regular valve at one end, and another end is the bell-mouthed entrance. Right. Another component part, another operators for the experiment is one glass. This is the glass tube. This is the glass tube. And this is one more valve here. This valve is used to regulate the velocity of flow from tank. Velocity of flow from the tank. Right? This is filament of dye. This is filament of dye. These are the component parts, or these are the operators of the Reynolds experiment. Working procedure. First, now we will allow water to pass through the glass tube from the water tank. This is the water tank. First allow water to out from the water tank. That is the first one. Regulating valve is provided here. This is the regulating valve. Regulating valve is provided here to change the velocity of water flowing through the glass tube. To change the velocity of water, that means small opening velocity is low. Gradually opening increases, velocity is gradually increases, right? This is the valve provided here to regulate the velocity of flow from the tank. Next one, allow a liquid dye. Allow a liquid dye. This is the dye provided here, but this dye, the specific weight of this liquid dye and the water flowing stored in the tank both are same. The specific weight of the dye and the water in the tank should be equal. Observations made by Reynolds. First observation, when velocity of water flowing low, so if the valve is opened, when the velocity of flowing low, dye filament will be in form of straight line in the glass tube. So if at the low velocity, the dye filament will be flow as a straight line in the glass tube, so that dye filament is in the form of straight line and parallel to wall of the glass tube. Right. It is observed that the dye filament in the glass tube is straight and parallel to the glass tube. Straight and parallel to the glass tube. Dye filament is straight and parallel to the glass tube. So it is an example of laminar flow. The lines are parallel, not cross each other, and straight. This is an example of laminar flow. Therefore, at low velocities, the flow in the pipe is, the flow in this glass tube is laminar. Therefore, the type of water flow will be laminar, right? And observation 2, now the velocity of flow is gradually increases. Now the velocity of flow by operating the regulating valve gradually increases. The dye filament in the glass tube is not in the straight line, that is in the form of wave. So this is an example of transition stage. This is an example of transition stage. Therefore, when the velocity of water flow through the glass tube is increased, the type of water flow will be transition flow. Therefore, when the velocity of water flow through the glass tube is increased, the type of water flow will be transition flow. Therefore, transition flow means the flow between the laminar and turbulent. Now the velocity of flow further increases. Wave dye filament in the glass tube is broken and diffused, right? Therefore, it is concluded that particles of dye filament liquid are moving in random and irregular fashion at this high velocity. There is no perfect path. This indicates that the flow in the glass tube is turbulent, right? This is about Reynolds number. It is Reynolds concluded that at low velocities the flow in the glass tube is laminar. If the gradually velocity increases, the flow in the laminar is transition. Again the velocity of flow increases, so the flow in the glass tube is turbulent. This is the last topic, characteristics of laminar and turbulent flows. What are the characteristics of laminar and turbulent flows? Laminar flow is the flow which occurs in the form of layers with no intermixing between the layers. Okay, laminar flow is the flow which occurs in the form of layers with no intersecting between the layers, having perfect path and parallel to each other and straight lines, not cross each other. That is the first property of the laminar flow. Next one, laminar flow is referred to as streamline and viscous flow. What is streamline? Is an imaginary line. At a point over the imaginary line, take a tangent. That tangent gives the velocity component in that direction, right? This is the streamline. And viscous flows. Viscous flows, that means that are real fluids. Viscous flows means real fluids. And another one is in case of laminar flow, the loss of pressure head will be proportional to the velocity of flow. The loss of pressure head formula P1 minus P2 divided by rho z. This is the loss of pressure head. Suppose this is one line, this is section 1 1, this is section 2 2, section 1 1 pressure P2, section 2 2 pressure, section 1 1 pressure P1, section 2 2 pressure P2, P1 minus P2 divided by rho g. This is the loss of pressure head is equal to 32 mu average velocity, length, and density g and diameter. Right? In case of laminar flow, the loss of pressure head is directly proportional to velocity of flow. This is one of the character of the laminar flow. Characteristics of turbulent flow. In this turbulent flow, there is a continuous intermixing of fluid particles. There is no definite path that are cross each other. Right? This is the first property of the turbulent flow. Another one is the loss of pressure head will be approximately equal to the or varies with respect to square of the velocity. Right? This is about characteristics of the laminar flow and turbulent flow. Here already we discussed about Reynolds number. Now based on the Reynolds number value, how classify the laminar flow, turbulent flow and transition flow in case of pipes? How classify the laminar, turbulent and transition flow in case of plates? Okay, that is only point here. Reynolds number is equal to rho is equal to mass density, velocity of flow, d is equal to diameter of the pipeline. In the earlier case we have discussed mu is the viscosity. Some cases this d is also characteristic length of the geometry. This characteristic length of the geometry is determined 4 AC divided by P. AC is nothing but cross-sectional area of the pipe. P is nothing but perimeter of the pipe. If they have not given diameter of the pipeline directly, then we are going to use by using this formula 4 into AC divided by P. AC is the cross-sectional area, P is the perimeter of the pipe. Then we have D. Right? If the D value is substituting here, we have some numerical value, that is the Reynolds number. If the Reynolds number is less than 2000 in case of pipes, that is laminar flow. If the Reynolds number is in between 2000 to 4000 in case of pipes, that is transition flow. If the Reynolds number is more than 4000, the type of flow is known as turbulent flow in case of pipes. Whereas in case of plates, the Reynolds number is less than 5 into 10 power 5, that is laminar flow. In case of plates, the transition flow is neglected, that is very small value. Transition stage is very less in case of plates. Then the Reynolds number is more than 5 into 10 power 5. That flow is known as turbulent flow in case of pipes. Thank you one and all.